everyone. And now please allow us to introduce ourselves. I'm Maddie as the leader of the group.
I'm Kimberly as the IT. I'm Jesslyn as the experimenter.
And I'm Kathy as the material manager.
The main activity that we're going to answer through our experiment today is, what is a double replacement reaction?
But before we continue, we will tell you the two main objectives for this experiment. The first objective is to be able to describe what happens in a double replacement reaction.
The second one is to be able to observe the formation of a precipitate.
So, as I said before, our main activity today is, what is a double replacement reaction? To be able to answer our question today, we are going to answer it by going through an experiment by adding water to potassium carbonate and also calcium chloride. Then we mix both compounds until it is mixed well. Then for the third step, we add both compounds into one container and mix well. And the final result will give us the answer for our main activity today.
Now, let us proceed to prepare the materials for the experiment.
For this experiment, we will need potassium carbonate, calcium chloride, and two 250 milliliters, a graduate cylinder, and a balance, and a steering rod. And also, the last one is filter papers. Now we are ready to start the experiment.
The first step, we need to measure 2 grams of potassium carbonate and 2 grams of calcium chloride. After measuring, we need to place each compound into a beaker.
For the second step, using a graduated cylinder, add 50 ml of water to the beaker with potassium carbonate and stir. For the third step, repeat the same process for calcium chloride and stir.
The last step, mix both solutions together and stir well.
after being dissolved in water. And for the first one, we're going to talk about potassium carbonate. After it dissolves in water, the potassium carbonate looks, the water I mean, it looks clear, transparent, and the potassium carbonate looks completely dissolved. And the second one, for calcium chloride, the compound, after dissolved in the water looks kind of white, but not opaque, no. And the calcium chloride has also completely dissolved. So basically, for the conclusion, for the experiment before, when we added potassium carbonate with water, the water turns extremely clear and transparent. And same goes for calcium chloride, in which once it dissolves, you can see that the water is clear and transparent with no reaction. But once we add two compounds together, which is potassium carbonate and also calcium chloride, which is dissolved in water, the water turns completely milky white, unlike before, which is clear and transparent. So, for the precipitate, we waited for several minutes. Then we can see a mixture in the bottom of the beaker called calcium carbonate, and also the second one is potassium chloride. In the chemical equation, we can say that it is CaCO3 plus KCl. Now, for the next terms, I have three of them. And the first one is double replacement reaction, the second one is precipitate, and the third one is solution. So, for the first one, double replacement reaction is a reaction in which elements from two different compounds replace each other, forming two new compounds. For the second one, which is a precipitate, is a solid that settles to the bottom of the mixture. And for the first one, solution is a mixture of two or more substances. And for answering the main activity, according to the term I just said before, double replacement reaction is a reaction from two different compounds replace each other, forming two new compounds. But according to me, double replacement reaction, also called double displacement exchange or metathesis reaction, occur when parts of two ionic compounds are exchanged, making two new compounds. That's all for the conclusion. And that's all. Finally, Ruwa would like to say, thank you for watching!